Good morning. This is Divyang, here to explain you a tech talk on definition and expansion of determinants of order 2 and 3. It belongs to subject linear algebra calculus. I am from aeronautical department and belong to section A. In order to understand the topic, first we need to know what are determinants. Determinants of a matrix represent a single value digit. We obtain the determinant of a matrix by multiplying and adding them in a special manner. First, we need to know matrix of order 2 and its determinant. Matrix of order 2 is a matrix which has is a square matrix which has same number of rows and columns. When we see here, matrix A11, A12, A21, A22 represents this square matrix. And the depth of this matrix is given by multiplication of first element to the diagonally opposite element at the end and subtracted by the third element multiplied with the second element of the matrix. When we observe carefully here, the multiplication takes diagonally between the elements and then subtraction is done. Matrix of order 3 and its determinant. Matrix of order 3 is nothing but a square matrix with 3 rows and 3 columns. The depth of, and to remind you, we can find determinants only of a square matrix. And the depth of matrix can be found by similar way of second matrix. First, we need to find the cofactor of the matrix. What is a cofactor of a matrix? It's nothing but the depth of secondary matrix divided here. Here it begins with only second and third rows taken separately in account. When we observe carefully, we find the depth to be like, what's that? Here A11 into A22, A32. Here cofactor of A22, A33 is given by here and then subtracted by second element multiplied with cofactor of it, then third element added with cofactor of it, gives the depth of the element. There are several properties of determinants. Some of them are the value of determinants unchanged even if the columns and rows are interchanged. Property 2. If any two rows or columns of a determinant are interchanged, then the sign of determinant changes. That is, when we change a row or a column of then we can change its sign and we get the same value. If sign is not changed, we get the negative value. Property 3. If any two rows or columns of determinants are identical, then its depth is equals to 0. As when we perform row operations, we get a complete row or complete column to be 0 and the total value gets 0. Fourth property, if each element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by the value of k. That is, when a whole matrix or bit is multiplied with k, we get its whole value to be multiplied by k. If we take in account the whole value of that is multiplied with k, we get the same value as of that k. Note, multiplying a determinant by k means multiplying only one row or one column. Or if we multiply all the rows and all the columns with k, then we need to multiply k cube to the depth of the value. Thank you.